Hello everyone, in this video we are just going to discuss in detail about the char data type in C language. Let's get started. So char data type is one of the default data types available in C language, and it has the maximum size of 1 byte of memory in CPU. So whenever we declare and define a variable based on this char data type, that particular variable can hold a maximum of a byte of data in the memory of the CPU, whether it is a computer CPU or a microcontroller CPU. And most often this char data type variables are useful for holding the ASCII code characters or the signed integer values within the range of a byte of data. So ASCII is nothing but American Standard Code for Information Interface. So this American Standard Code for Information Interface is a particular standard framed for aligning and representing the English alphabets and special characters to a particular integer. That is, you can clearly see in this table there are 128 numbers starting from 0 to 127, and for each number there is a specific special character or alphabets aligned for that particular number. For example, you can clearly see the alphabet capital A in English is represented by the decimal number 65. So if we store the number 65 in the memory, that means as per the ASCII code that is representing the capital A. And in a similar fashion, if you want to store the character small a, you just want to store the number 97 in that memory. So for representing these kinds of alphabets and all these special characters available in English alphabets, you can use this ASCII code in your program. So let us discuss in detail about the ASCII codes in a separate video, and for now understand that this particular char data type is useful for storing these ASCII code values, that is from 0 to 127, which will be representing a particular special character or a English alphabet. And also you can use this char data type variables for storing a number within a range of byte of data. And let us discuss in detail about the range of value that can be stored in the char data type. If you are using and declaring a variable using signed char, or if you are not using any type qualifier, that will be assigned as a signed data type, and it will be holding the values between -128 to +127. And if you are using the unsigned version of the char data type variables, it will be holding values from 0 to 255. And if you want to access the number, or if you want to store and access the number greater than 255, you just want to move to another data type variant that we will discuss later. For now, the char can hold a maximum of 0 to 255 in unsigned version, and in signed version it can store numbers between -128 to 127. So this is the range of char data type. Now let us discuss how a variable is declared and defined in C language. So this is the basic syntax for declaring and defining a variable in C language, that is data type name space variable name, and at the end you just want to provide the semicolon, and here in our case the data type name is nothing but char, and variable name can be anything as per your requirement. You can clearly see here I have declared a variable of name variable underscore name and defined it in a char data type variant. So char space variable underscore name declares and defines variable of the name variable underscore name of the type char, and it is having a value between -128 to 127. You can store the values between -128 to 127 if you are declaring the signed version like this, and if you are declaring the unsigned version of char, you can store the values between 0 to 255 in this variable underscore name. And now let's try to understand how data are stored in the memory of the CPU when you are declaring and defining variables based on this char data type. So you can clearly see on the screen, this is the 8 bits of data, that is 1 byte of memory in the CPU. Assume that this is the 1 byte of data that is allocated for this variable underscore name. And often a byte of data is represented like this, that is 0 starting from right and it goes on till the maximum value in the left. So the 0th bit on the right is nothing but the LSB of the data, that is the least significant bit of the data, and 7th bit, that is the final bit on the left, is nothing but the most significant bit of the data. So since we are having only 1 byte of data, that is 8 bits of data in our char data type, we are having only this much amount of memory for this variable underscore name, or for any variables that you are going to declare using this char data type. Let's understand the unsigned version of char. When you declare and define a variable using this unsigned type qualifier in this data type variant char, all the 8 bits is assigned for storing the magnitude of number, that is the number is stored as a whole of 8 bits in this memory. So the minimum value that can be stored in the unsigned version of char is all zeros. So all zeros is nothing but, when I convert this binary 8 bits of zeros into decimal or hexadecimal, I will be getting the value to be 0. And the maximum data that can be stored in the unsigned version of char data type is every single bit is 1, right? So all the bits will be 1. So I will get 1 1 1 1 1 1 1 1 as the maximum value that can be stored in this 8 bits of memory location. So this binary 8 bits of ones can be converted into hexadecimal and then it can be converted into decimal. Let me just do that. I am just opening the calculator, and in the calculator select the programmer type calculator and then click on this bits. So here you can see I am having n number of bits from 0 to 63, but I am just going to utilize only these 8 bits in the LSB of the bits. So I am just going to provide 1 1 1 1 1 1 1 1. So this binary data is represented as 255 in decimal and FF in hexadecimal. So decimal value is 255. So in such a way only the maximum stored value in unsigned char is reached, and the minimum value that can be stored is 0 in unsigned char. So this is how the range has occurred for this unsigned char variant. So I hope you understood how these two values from 0 to 255 has been assigned to this unsigned char based variables when you declare a variable based on unsigned char data type. And let us discuss in detail about how the signed variable in char assigns and stores the data in memory. So now you can see, when you declare and define a variable using the signed variant of, that is this one, what happens is the 8 bits of memory is split into 2 parts. One is the MSB bit and other 7 LSB bits. And the MSB bit is nothing but the signed bit of the data, and the LSB 7 bits are nothing but the bits that is useful for storing the magnitude of data. That is, the data as a whole is stored only in 7 LSB bits, and the most significant bit, that is the 7th bit in this variable, is useful for indicating the sign of the number. When the sign bit is having the value 0, that means it is representing that the value stored in the memory is a positive number. And when we have the number or bit number 1 in the sign bit, it is representing a negative number stored in the memory. So that much simple as it is. When the number is 0, that represents a positive number, and when the sign bit is having the value 1, it represents a negative number stored in the memory. So let us take an example for understanding how a number is stored in the signed data type variant of this char data type. So let's take the number to be 37. So if I want to store the number 37, it is a positive number, right? So the sign bit will be holding the value 0, indicating that the number stored in the memory is a positive number, and then the 37 is directly converted into binary format and it is stored right over here. So 0010 0101 is the binary representation for the positive number 37, which will be stored in the memory of the CPU. So let me just open the calculator. I am just typing the number 37. You can clearly see this is the binary representation of the number 37, which will be stored to the memory directly. So that much simple as it is. You can clearly see the positive number is easily converted into hexadecimal and then it is converted into binary and it is stored in the byte of data. And when you try to store a negative number, let's take the negative version of the same number, that is minus 37. Now as I mentioned, the sign bit will be holding the value 1. And now when I want to store this number 37, the number 37 will be stored like this. That is, the minus 37 is represented like this, that is 1101 1011. So 1101 1011. So this is nothing but 219 in decimal. Now what we want to do is, I just want to subtract this number with the maximum number that can be stored in char data type for arriving this number minus 37. So maximum number that can be stored in the char data type variable is 0 to 255. The total numbers is nothing but 256 including the number 0. So I just want to subtract this number with 256 for arriving the actual number. You can clearly see the number minus 37 has been stored in the form of 219 in the memory. Since this 8th bit is holding the value 1, the number is a negative number. So in this manner, the negative numbers are stored in the char data type based variables, and if you declare and define variables based on char, you can have the range between minus 128 to 127 in the signed variant, and for unsigned variant you will be having the range between 0 to 255. So before declaring and defining a variable, the analysis must be performed by the programmer whether this particular variable goes beyond this limit or it will be around only within the range of this data type limit, declaring and defining the variable of char type. So this is the simplest form of data type available in C language, which will be holding this range. And let's test whether, and now let's test the minimum and maximum range of signed char data type. That is, the minimum range goes on like this, that is the minimum range is nothing but minus 128. So as I mentioned, the sign bit will be holding the value 1 in case of negative number, and the minimum value that can be stored in this magnitude is 0000000. So this is the minimum number, right? So this is the minimum number that can be stored. Let me check whether what is this number. So 10000000. This is nothing but 128. So negative of 128 comes like this. So the minimum number that can be stored is nothing but minus 128. This is how this minus 128 range came into play. And let's test the maximum number that can be stored. So the maximum number will be always positive. So the sign bit will be holding the value 0. And the maximum number that can be stored in the 7 bits of memory is 1111111. So let's test what is this number. I am just opening the calculator. 01111111. It is nothing but positive 127. So this is the maximum number that can be stored in the signed version of char data type. That is the char data type with type qualifier signed. Or you can neglect the signed sign. It will be by defaultly signed char data type. So this is the minimum number and this is the maximum number, and for unsigned char the minimum is 0 and maximum is 255. And you can see here, this is the previous program that we wrote for printing the hello world to our output window, right? So let me just build this code whether it is functioning or not. Yes, it is functioning. You can clearly see the hello world has been printed to the output window of the dev C++ IDE. Now what I'm going to do is I'm just going to declare and define variable of char data type. So as I mentioned, the syntax for declaring and defining a variable in C language is simple: data type namespace variable name colon. This is the syntax. In place of this data type name, you can provide the data type name, that is nothing but char in our case, and in place of this variable name you can provide whatever name you want. I am just going to declare a variable of name one, and now the declaration and definition of the char variable is done with the name one. So now what I can do is I can use this memory space of char data type variant wherever I want to store a particular byte of data, and also for retrieving that particular byte of data using this name one. So now I have declared and defined variable of char data type and assigned the name one. So now from here on in this program I can use this name one for storing the values within the range of -128 to +127, and also for retrieving the data I can use the same name. So for storing some data to this memory location, I can directly write like this: one is equal to 37. And for retrieving the name, you can use the same assignment equal to operator for retrieving the data. And for printing and visualizing the data using printf, you can do like this. That is, I am just going to print variable 1 value is %d, 1. When I write like this, you can clearly see it will be printing variable 1 value is, and this %d is nothing but an identifier which is useful for printing the integer values from a particular variable. So instead of this %d, the variable value provided right over here, that is the one variable value, will be printed. So I will be getting the output variable value is 37. Let me just test this. I am just compiling the sketch. 0 errors and 0 warnings. I am just going to run the program. You can see the variable 1 value is 37. The output is as expected. And now when I try to load a negative number -37, the result will be same. The variable 1 value is -37. Let me just test this. You can see the variable 1 value is -37. So as I mentioned, the range of the signed version of char is -128 to 127. So when I exceed this range, let us test what is happening. Let me just store the value 129. I'm just running the program. You can see I am getting some other value, that is -127. So value has been exceeded. So it is going to the initial value -128 and it is printing the -127. So it is rotating. You can clearly see the maximum range is 127. So after 127, it is taking up the value -128 and again it is taking up the value -127 because of 129 stored. So the maximum limit of this signed char variable is -128 to 127, and for storing this 129 and until the value 255, you can provide this unsigned type qualifier before this char, so that this one variable will be capable of storing values between 0 to 255. Now when I run this, you can see the output. The variable 1 value is 129. So this variable can hold the maximum value of 255. You can see 255 has been stored, and when I exceed this, when I provide 256, the value stored will be 0 because it will be rotating to the beginning, and when I provide 257, the value will be 1 again because 255 is the maximum value, 256 will be rotated to 0 and 257 will be rotated to the value 1. Let me just test this. You can see the variable 1 value is 1. So the maximum value is 255. You can see the warning here, the large integer implicitly truncated to the unsigned type. That is, it is mentioning that the variable has overflown. So I hope you understood what is a char data type, what is the unsigned char data type, how data is stored in signed variant of the char data type and unsigned variant of char data type based variables. See you in the next video. Thanks for watching.